Hello everyone, in today's video we're going to take a look at an example of implicit differentiation. Okay, so here's the question. We're given some function which is expressed implicitly, which says that x squared plus y squared plus 10x plus 2y take away 4 times xy is always 10. And part A is to find dy dx in terms of x and y. And part B is some kind of application. Let's find the values of y such that dy dx equals 0. Okay, so let's jump in. Here's our solution. Okay, so firstly, what does implicit mean? Take a look at the function. Well, what it means is it's not written in the usual format of y on the left and then all the x's on the right. We cannot do that, well, not in an easy way at least. The best we've got is just some kind of mixture of x's and y's, which is very much like this question. We can see all the x's and y's mixed. Okay, so the approach for finding dy dx is always the same. You just jump straight in and differentiate both sides with respect to x. Okay, so let's start on the left hand side. Differentiate x squared with respect to x, nice and simple, 2x. The next term, differentiate y squared with respect to x. It's important to remember that y just contains loads of x's. We don't know what it is, but we know all the x's are inside of y. So what we're going to do, we're going to apply the chain rule, and there's a simple way to do this. If you differentiate in some y's with respect to x, well, differentiate in the usual way, so bring the 2 down, so you have 2y squared. Because we're differentiating with respect to x, you need to tag on a dy dx. Okay, this approach always works. The third term, well, just differentiate 10x with respect to x. That's just 10, nice and simple. The third term, we have some y's. Okay, so I give you y and say differentiate with respect to x. Well, that's just dy dx. We have a 2, no big problem. We can times it by 2. We want to add. So that's just 2 dy dx. Now this term, this is the hardest term. This is where it's easy to lose a lot of marks. So what do we have? We have a a 4x sitting there, and a y that sits there, but that y contains all the x's. So we need to differentiate this product, and the way we do that is the product rule. Okay, so the factors are going to be 4x and y. So put that into the product rule, differentiate 4x, you get 4, keep y the same, plus keep 4x the same, differentiate y, dy dx, and this equals the derivative of 10 with respect to x. 10 is a constant, so that differentiates to 0. Okay, so we're about halfway through finding dy dx. We've powered through the differentiation. Now a bit of algebra. So next we need to collect together all these dy dx's. So I think I'm going to highlight them, and I'm going to have a think about my approach. And I've decided the way I'm going to do this is put a dy dx here and see how many I have. So this term, let me highlight it. This term here has a 2y in front of dy dx. That's that one done. And this term has a 2 in front of dy dx. So I'm going to add 2. That's that one done. This term here has a 4x. There's a bracket with a negative here. So this is minus 4x dy dx. Deals with that term. And next I'm going to collect whatever's left over together. So I can see there's a 2x, there's a 10, and there's a 4y. Don't forget the negative. That equals to 0. Okay, so now I just need to rearrange all of this to get dy dx on its own. To do that, I need to put all of this on the right hand side and then divide by all of this. Okay, so let's do that next. Okay, so I have dy dx equals, so take everything over, 4y minus 2x minus 10, all divided by 2y plus 2, take away 4x. So are we finished there? We got dy dx in terms of x's and y. Yeah, kind of. Actually, I want to do one more thing. I can see even numbers everywhere. I'm going to divide everything by 2 just to make it look a bit nicer. I think it's going to make the next step a bit easier. It's not absolutely essential, it just looks nicer. So there you go. Here's our dy dx in terms of x and y. Okay, so that's part A. Now on to part B. We want to find out when is dy dx equal to 0. Well, we have a fraction. A fraction is 0 when the top is 0. So this means we require the top of the fraction, which is 2y, take away x, take away 5 to be 0. And if we just rearrange that a little, I'm going to take the minus x to the other side. We have 2y take away 5 is the same as x. So this is our relationship when dy dx is 0. And we want to find out when is this, so what values of y will make dy dx 0 using this relationship. Okay, so we got the relationship between x and y. What we're going to do with that? Well, we know from the question there's also another relationship between x and y. For all x and y, we know the relationship from the question is x squared plus y squared plus 10x plus 2y take away 4xy is always 10. So what we're going to do, we're going to substitute our relationship here into this equation. Okay, so let's do it. So wherever we see x, we're going to replace with 2y take away 5. So we want to square x, and we want to times x by 10, and we have a 4 times x times y equals 10, and our answer is the solution to this equation. Okay, so we got a bit of algebra to do, it seems. So let's begin to multiply out the brackets. So the first term, square the first, 4y squared, 2 times the product, so minus 10y minus 20y plus 25. That's the first term. The second term is just y squared. The third term is 20y take away 50. So I've done the first three. The fourth term, I've got 4 and a y. I'm going to put those together. So it's minus 8y squared plus 20y, and that all equals to 10. Okay, collect everything together. What do we have? Okay, let's begin. Let's just highlight some of these terms. So the y squareds are here. How many y squareds do we have? 4 plus 1 is 5. Take away 8 is minus 3. Lots of y squareds. Now how many y's do we have? Okay, so we have minus 20 plus 20, so they cancel. We have just 20 left over. Let's just double check that. It's easy to make mistakes here. So we have plus 20, yes, and yeah, okay, so they cancel. We have 20y. And how many constants do we have? We have 25, take away 50, and if we bring this 10 over, so what's that, minus 25 minus 35 equal to 0. Okay, so now we need to solve this. Let's just check we've done all this right. So we have x squared, this one squared, this one. Oh, I've missed the 2y. Oh, okay, here, I'm missing 2y. Okay, I just noticed there's a 2y missing. I'll just drop that in there, 2y. Okay, and this one then is going to actually go to 22y. Okay, small mistake there. I'll just fix that. Okay, so I need to solve this quadratic. There's a negative sitting at the front, so I think I'm going to times through by minus 1. Let's do that on a clean page. We have 3y squared minus 22y plus 35 equals 0. A little bit of factorization. For 3y and a y, we need two numbers here that multiply to 35, and then we need to check the cross terms for minus 22, lots of y. So a little bit of playing around with these numbers. We see that is minus 5 minus 7. That equals to 0. So finally, the values of y that we're looking for are 7/3 and 5. And there you go. That is the end of the problem.